Hello everyone, welcome back to my YouTube channel. So today we have this problem: 3 raised to power b minus 2 raised to power b is equal to 65. So how are we going to be solving it? I'm going to be showing you the trick to actually solve this problem in this video. So make sure you give this video a thumb up, subscribe to our channel for more updates, and also turn on the notification icon so that whenever we release more content, you will actually get to know about it. Of course, you can also follow us on Facebook. You can actually like and also share this video so that your friends will also get to also enjoy it and then see how to solve this kind of problem. So having said that, we're going to proceed with this. Okay, so let's dive into the solving. Okay, so what we are going to be doing is, let me first rewrite the problem. 3 raised to the power b minus 2 raised to the power b is equal to 65. So what we are going to be doing is, we actually want to do some changes on the question which will not actually affect anything. So what I want to do is, I want to rewrite this as 3 raised to the power b, or bracket 2 raised to the power 2 minus 2 raised to the power b, or bracket 2 raised to the power 2 also, and this is equal to 65. And of course, you know that I have not actually changed anything because 2 raised to the power 2 is actually 1. Okay, I have not actually changed anything. Now I want to use a property which is actually the power law, which basically say that if you have let's say a raised to the power b and also raised to the power x, this you can also write as a raised to the power x, okay, brackets b. That is, you can actually exchange the powers of, or you can also write all of them together. So this is one of the laws of indices which I'm going to be using here. So I can actually rewrite my question to be in this form: 3 raised to power b, okay, the divided by 2, okay, or raised to power 2, minus 2 raised to power b, or divided by 2 raised to power another 2, okay, and it is equal to 65. Okay, so this is what I have, and then what I'm going to do now is, I actually want to set these stuffs inside the bracket to be something, so that I will actually reduce the question and then I will have lesser things to deal with. So what I'm going to do is, I can set my 3 raised to the power b divided by 2 to be equal to x, and then I will set 2 raised to the power b divided by 2 to be equal to y. So if that happens, what I'm going to be having is x raised to the power 2 minus y raised to the power 2 is equal to 65. Okay, so this is what we have currently. So how do we simplify? Now we are going to be using the difference of two squares, which basically say that x squared, or that a squared minus b squared can actually be written as a plus b bracket a minus b. Okay, so I'm going to be using that property there, so I can write this as x plus y, okay, and then x minus y, and this is equal to 65. Now I want to work on the right hand side, and if I work on the right hand side, I want to express 65 as the product of 13 times 5. Okay, so doing that, I will have x plus y, x minus y is equal to 13 times 5. Okay, so we are saying that the product of these two elements will actually give us 13 times 5. So which of these will actually give 13 times 5? Well, we know that x plus y will always be bigger than x minus y, since x and y are both positive. If that is the case, we can have that it is actually our x plus y that is equal to 13, and then our x minus y will be equal to 5. So I'm going to split this question in this way. So I will have that x plus y is equal to 13. I can call this one equation 1, and then x minus y will also be equal to 5. Okay, so I can now go ahead and solve these two equations. Okay, let me name this equation 2. I can go ahead to solve them simultaneously. So what I'm going to do now is just to add equation 1 to equation 2. So doing that, I'm going to be having 2x, okay, this one is gone, is equal to 13 plus 5 is actually 18. So what I'm going to do is I will divide through by 2 so that I will have that my x is equal to 18 divided by 2, which implies that my x is equal to 9. Okay, now moving further, I can come back to this again, and then to get my y, what I'm going to do now is just to subtract equation 1 from equation 2. And then if I do that, this minus this is gone. Y minus y will give me 2y is equal to 13 minus 5 is actually 8. And then of course I'm going to divide it through by 2. From there I'll get that my y is equal to 4. Okay, so we've gotten that our x is equal to 9, and then our y is equal to 4. Okay, but we actually set our x to be equal to 3 raised to power b divided by 2, so which implies that 9 is now equal to 3 raised to power b divided by 2. Okay, so I can express 9 as 3 raised to power 2, and then is equal to b 3 raised to power b divided by 2. So since the base are the same, I can go ahead and cancel the base, and then I will equate the powers, which is 2 equal to b divided by 2. Okay, so I can multiply through, and I'll have that my b is equal to 4. Okay, now also I have that my y was set to be 2 raised to power b divided by 2, but I have my y to be equal to 4, which is equal to 2 raised to power b divided by 2. Okay, so I can express 4 as 2 raised to power 2 is equal to, okay, 2 raised to power b divided by 2, and then this can cancel this, and I will have that my b is equal to 4. Okay, so you can see that whether we are getting our b from x or we are getting it from y, our b is equal to 4. And of course, don't forget that the question we are actually solving is that 3 raised to power b minus 2 raised to power b is equal to 65. So what I want to do now is whether b equal to 4 actually satisfy this equation. Okay, so if we substitute b for 4, we're going to be having that our 3 raised to power 4 minus 2 raised to power 4 should be equal to 65. So is it correct? So, and of course, you know that 3 raised to power 4 is actually 3 times 3 times 3 times 3, and it minus 2 times 2 times 2 times 2 is equals to 65. Now 3 times 3 is actually 9. 9 times 9 should be 81, minus 16 is equal to 65. And of course, if you subtract this, you actually see that this is equal to 65 and it's equal to 65. So our answer is actually correct. So that is how you can actually solve this kind of problem when you have it. So thank you so much. And of course, if you have not subscribed to our channel, please do well to subscribe to our channel and then support what we are doing right here. Share this video to your friends and also like this video too. And I'm going to see you guys in my next video. Bye.